So here is a question. The following figure shows overhead views of the four situations in which two forces are acting on the same block of mass 1 kg. The acceleration of the block across a frictionless floor. Rank the situations. Okay, so you know that if 3 newtons and 5 newtons are acting in the same direction, the total force will be 8 newtons, so it will have the maximum acceleration, A max, in the case of 1. And you have a 5 newton and a 3 newton acting in the opposite direction, so net force will be 2 newton, 5 minus 3, so the acceleration will be comparatively lesser in 2. Let's do the third block. You have a 3 newton and a 5 newton, and the resultant will be root of 25 plus 9, which is a root of 34. Whereas in the fourth block, it's 3 newton and a 5 newton, and according to parallelogram law, it's a square plus b square plus 2ab. 15 plus 30 cos angle, whatever be the angle, it's only an acute angle, which will lead you into a fraction, but still it's getting added. So then the case 4, the fourth case will have the maximum acceleration. Fourth case will have, when compared to this, it will have a maximum acceleration, but however the case 1 is which has got maximum acceleration, and the opposite direction will be the minimum, the lowest of the low will be this. So then next will be case 3. Now case 4 will have the maximum, then case 3, and then case 2. 1, 4, 3, 2. So option C is the answer. Yes, option C is the answer. So that completes this question. The next question is here. A block of mass 1 kg lying on the floor is subjected to a horizontal force of F is equal to 2 sine omega t. The coefficient of friction between the block and the floor. So if it's going to be subjected in the horizontal direction, the frictional force will be here. And the coefficient of friction, mu is equal to 0.25. So frictional force is equal to mu into normal reaction. If this is going to be mg, the normal reaction will be, this is 10, the normal reaction will be here, which is also 10. So frictional force is equal to 0.25 into 10. So frictional force is 2.5 Newton. And you know, any sine's value, they haven't specified what is omega t, but you can say that sine theta lies between -1 and +1, assuming it's +1, because the force is only positive. The applied force is 2 Newton, whereas the frictional force is 2.5, therefore the block will not move. The block always remains at rest. So the C is the answer, because whatever be the value of f is a function of f is a function of omega t, and whatever be the value, it's always going to be less, so it's always going to be not moving. So that's what it is, the block will be at rest. So let's go to next question. So let's look at the next question. The block of mass 2 kg is placed on the floor. The coefficient of static friction between the two surfaces, nu static is 0.4, and you know that the horizontal force of 2.5 Newton is applied, and the frictional force will be in this direction. Friction force is equal to mu into normal reaction. This is 20, and hence the normal reaction will also be 20. Mu is 0.4 into 20, so which makes it, when you multiply, you get 0. Okay, you get an 80 with decimal here, so you get frictional force to be 8 Newton, and so 8 Newton is always greater than the applied force of 2. Is greater than 2.5 Newton, so the block will not move. What is that? The force of friction between the block and the floor. Okay, so since 8 Newton is greater than 2.5, this means the object will not move. Yes, when the force applied on the block is less than the limiting friction, then the frictional force will be equal to the applied force. Okay, so and you know from the diagram, the frictional force increases as the applied force increases. This is the applied force. As the applied force increases, frictional force increases, and then it reaches a maximum and then comes down, and this region is where the static friction is. This is limiting friction, it's Fs maximum, and this is kinetic friction, as you know. So the value of friction until it reaches the maximum is always equal to the applied force. So the final frictional force will be Since the applied force is 2.5 Newton, so we will not say friction to be 8 Newton. So we will just say that friction is only 2.5 Newton. It's because the applied force until for a certain value of applied force, the frictional force is always equal to applied force. Only after a particular value of applied force, when it's able to, when it is greater than the frictional force, that's when the object will start moving. So that's 2.5 Newton, and that too in the opposite direction of the applied force. This is the answer. Here is the next question. A block A of mass 2 kg is placed over a block B of mass 8 kg. The combination is placed on a rough horizontal surface, which means there is friction. If G is equal to 10 meter per second square, the coefficient of friction between the B and the flow is 0.5. The coefficient of friction between the A and the B, here the coefficient of friction is 0.4. So it's mu dash and mu. And the horizontal force of 10 Newton is applied on 8 kg. A force of 10 Newton is applied on 8 kg block. Then the force of friction between A and B. So there's a 2 kg block over which there's an placed over an 8 kg block, and there's a coefficient of friction 0.4 and 0.5. Let's call this as mu, coefficient of friction. Mu dash is the coefficient of friction between the floor and the 8 kg block. 10 Newton force is applied, and when it's applied in this direction, there will be a frictional force in this direction. The total weight that is acting downward will be 10 kg, so mg is therefore 100 Newton. And this frictional force is equal to mu into normal reaction, where that mu corresponding to that 0.5 into normal reaction, which is 100, so it's 50 Newton. So the 10 kg block, it will definitely not, the 10 Newton applied force will not be moving the 50 Newton block. Okay, but this is the way to do this, some very easy, but however I'll just show you how to do the vector resolving. You know, this is the applied force, and you have to take the free body diagram. Say supposing you are taking the 2 kg block, you know that there will be a 2 kg block, so 2g which is acting downward, or 20 Newton which is acting downward, that will be equal to the normal reaction of it. So yeah, anything to the top one we are calling it as mu and n. Anything with respect to the bottom we are calling it as mu dash and n dash. Okay, so then when you're going to push the bottom block towards the right, the top block could go backwards, and so the friction in this block has to be in this direction. This is the direction of the friction in the top block. Okay, so take the bottom block now. Let's resolve that. You will already have the applied force which is acting in this direction, and since it's going towards the right, the frictional force will be acting in this direction, which I'm going to call it as F dash. That's the friction that exists between the lower block and the flow. Apart from that, this F, which is already on the right here, which is between the layers, so there will also be an equal and opposite force here. F will be there, and what else? There will be a normal reaction for this, which I'm going to call it as N dash, and that N dash will be equal to the that N dash will be equal to, okay, that N dash is acting vertically above it. So then there is this 8 kg block here, which will contribute to 8g as 8 or 80 Newton. Other than that, the 2 kg blocks will also be acting it has a normal reaction like that, so it will exert a normal reaction down on it. So then that will also come here, or in that will also be coming here. So then that's what it is, and so then therefore, when you're writing if you want to find what is F dash, it's mu into normal reaction, which is N dash, and according here it's N dash itself is 10 kg or at 100 Newton. So F dash is equal to that 0.5 into 100 Newton, and so it gave you 50 Newton, and so then the applied force is 10 Newton, the block will not move. Okay, yeah, so that's about it. Next question. is a block of mass 2 kg, which is A, which is 2 kg, is placed over a block B, which is 8 kg. The combination is placed on a rough surface, horizontal surface. It's got a coefficient of friction there. If G is equal to 10 meter per second square, coefficient of friction between B and the flow is mu is equal to 0.5. And between A and B, let's call this as mu dash, then we'll call this as mu, which is 0.4. And the horizontal force of 10 Newton is applied, similar to last sum, is applied on the 8 kg block. The force of friction between A and B. The last sum, whether it will move, that was the question. But in this, here, the question is to find the force of friction between A and B. And you know that I have already taught you how to do the free body diagram 2 kg. Since the applied force is towards the right, this block will go towards the left, and so the frictional force will be in this direction. And there will be a normal reaction, and there will be 20 Newton or a 2G which is acting down. And take the 8 kg block. The 8 kg block with the floor will have a friction here, because the move towards the right will have an F dash. There will be a normal reaction N dash, which will be countered by an 8 kg plus 2 kg, so 8 Newton which is acting downward, plus 8G plus a 2G also which is acting downwards will be 10. You already know that. And additionally, because of this F which exists on the frictional force on the top block to the lower block will also exert a friction on the top block, which will be F. So you have this, all these have been written. Now the question is to find the friction that exists between A and B, means they are asking for this F. Okay, they are asking for this F. Okay. So in the sum, they have asked you to find the small f, and it's the same as the last sum where no other values change, 0.4, 0. Same thing. So then therefore you know that the applied force is definitely lesser than the frictional force. We calculate the total frictional force, that is F dash with the ground, is 50 Newton. And so then therefore it's lesser than 10 Newton, so it's not even going to move. When it is not even moving, there is no motion, there's no movement of the bottom block. So obviously so we can say that this F and this F is going to get cancelled, so the net frictional force that exists between A and B is equal to 0. Because as you know, only as the applied force increases, the frictional force will also increase. So which means there is no applied force which is acting between the blocks, and so then the frictional force is 0. Very, very tricky. Okay, so that completes the sum. So here is a question: a block of mass m, a small m, is kept over a larger m floor. That's an applied force. A block of mass m is kept over another block of capital M, and the system rests on a horizontal surface. A constant force acting on the lower block produces an acceleration A is equal to F by 2 into small m plus capital M. In the system, the two blocks always move together. Okay, there is no relative motion. Consider displacement d of the system. The displacement d of the system until there is no relative motion between small m and capital M. Find the work done by the friction on the bigger block. A. Find the work done by friction on the bigger block. B. The coefficient of kinetic friction between the bigger block and the horizontal surface. C. Find the frictional acting on the smaller block. Find the work done by the force of friction on the smaller block by the bigger block. Find the work done by static friction on the bigger block. Okay. So they have already given that the entire system is moving with an acceleration of F by 2 into small m plus capital M. And the top block is not sliding over the bottom block. They both are accelerating as one unit. You have a common acceleration covering a distance of d. Okay, so now find the work done by the friction on, okay, as I said, the free body diagram, let's do the free body diagram. This is M. I think I did it before, but I rubbed it. So this is a mg which is reacting here, and there will be a normal reaction here, And since when the applied force is like this, there will be a frictional force which will be acting in this direction. Okay, and let's draw the lower block. No, normally when the applied force like this, the system will move in, and the our top block will tend to move backwards, and to prevent that, the frictional force has to happen like this. Okay, to prevent it, since it's not moving, so frictional force will be in this direction. And so then here you have capital M plus small m into G, which will be N dash for the bottom block, and the applied force will be here, and there will be a frictional force F dash here, because when you're moving it to the right, the frictional force will be in the opposite direction. Apart from that, you'll also have this F is there, so an equal and opposite force will do exist here. Okay, and that is the friction between the two blocks. That will be the friction between the two blocks. Okay, so now what is the question? The question is about find the work done by the friction on the bigger block. So they're talking about by the friction. What is the friction? Is F dash. On the bigger block, there is only F dash, and F dash is equal to mu into N dash, which is mu into capital M plus small m into G. And when it is moving with a constant, when it produces an acceleration, mu can be written as A by G into capital M plus small m into G, because when it is accelerating, you know that frictional force is equal to mu into normal reaction, which is mu into mg, which is also equal to, when it's accelerating, it can also be equal to ma. So m and m get cancelled, so mu is equal to a by g. Whenever there's an acceleration, you remember this formula. So then, but already you know what is the value of a, which is given in the question. So when you substitute it back here, it's f by 2g. G and g anyway get cancelled, so f by 2 into small m plus capital M into capital M plus small m. So this and this get cancelled, so f dash is equal to f by 2. The applied force, or the half value, is the frictional force, and the work done by the frictional force is f dash into d, considering it's moving through distance. It's got to be negative because it's a frictional force work, so f by 2 into d. And this answers the first question, which is the A part. And let's go to B part, where the coefficient of kinetic friction between the bigger and the horizontal surface. Kinetic friction is when kinetic friction occurs when the body is moving with a constant velocity, and so when obviously the frictional force and the applied force will be the same. When the frictional force and the applied force will be the same, so that frictional force is called kinetic frictional force, or coefficient of kinetic friction into normal reaction. So yes, you have the coefficient of kinetic friction is there. Yeah, the whole coefficient that you're using is based on it's already moving only. So then coefficient of friction, can we say that ma is equal to mu into g? Ma is equal to mu into g. Ma is the force, and mu into g. Ma is equal to mu into mg. Okay, the second part, find the coefficient of kinetic friction between the block. Okay, let me see the solution once again. So this is what it is. We got f minus f by 2 into d. In the case of kinetic friction, you should know that applied force is equal to the frictional force. The applied force here is f by 2, and the frictional force is mu into, again, normal reaction only. And f by 2 into mu into normal reaction is a capital M plus small m into g. So from this you can calculate what is mu, but this mu which comes into existence is the coefficient of kinetic friction. So then I think they're asking you to find the coefficient of kinetic friction only. So then if that is the case, this becomes mu k. So the coefficient of kinetic friction that exists is f by 2 into capital M plus small m into g will be the coefficient of kinetic friction. So that is done. C, when the friction acting on the smaller block? what is the friction acting on the smaller block? They both are moving as one unit. Okay, both the top block and the bottom block actually moving. So we can't say that the in between the force will be zero, the net friction will be zero. We can't say that. In the previous sums, it wasn't moving at all. The applied force was lesser than this frictional force F dash. So, but this question is different. It's moving. So what's moving with what? A mass into the acceleration, which is small m is the mass of the upper block, into the acceleration which is given in the question as F by 2 into capital M plus small m. So this is the mass into acceleration of the lower block, and the static friction always is equal to the applied force. So since this is the applied force on it and it's not moving, so then the Fs is equal to this is applied force, because the top block is not sliding. Okay, the top block does not slide, so m into F by 2 into m. This is the value of static friction, and friction acting on the smaller block. So this is the value of the friction acting on the smaller block, which is actually a static friction. D is find the work done by the force of friction on the smaller block by the bigger block. You already know that the in between that the only static friction is on the top and bottom. There's only static friction. That into D, the work done by the force of friction on the smaller block by the bigger block will be this Fs into D. That will be the work done by the force of friction on the smaller block by the bigger block. Let me see if it's correct. Yeah, the work done by the frictional force on the smaller block by the bigger block. Yes, we got this. Okay, so next part is E part, wherein they're asking find the work done by the static friction on the bigger block. This is the bigger block on the smaller block. Smaller block on the bigger block will be minus m into F by 2 into m plus m into d. So work done on the bigger block is negative. Okay, let me see what I have drawn here. Yes. So can you see that this is in the negative direction? So then therefore the work done on the bigger block is negative, while the work done on the by the frictional force on the smaller block, can you see from here, it is positive. By the F and F in the opposite direction, you can infer that. So such a beautiful question. Okay. So let's do this question here. A small block of 20 kg lies on a bigger block of mass 30 kg, which lies on a smooth horizontal plane. So you have a smooth horizontal plane, which means there's no friction. Initially the whole system is at rest. Okay, the coefficient of friction between the blocks, that is this block, is 0.5, and the horizontal force of 15 Newton is applied on the lower block. Between the blocks is 0.5. There is no coefficient of friction between the lower block and the floor, because it's smooth. So this is 0.5, 20 Newton, 30 Newton. Okay, now A, find the work done by the frictional force on the upper block and on the lower block in time t is equal to 2 seconds. So if you see this question, initially the block is not moving. Both the blocks are not moving, but 50 Newton is applied. There is no friction at all in this direction. So it's a smooth surface, which means since there is no friction, what did I do? Okay, one second. Okay. Since there is no friction here, it's a smooth surface, so the entire 50 Newton will easily move the entire mass of 20 plus 50 into g. 20 plus 50, yes, is the mass into gravity. Okay, so it will move the entire, this is the downward vector, but it will move the entire mass into acceleration. F is equal to m into a. With ease it will move because there is no friction. m itself is 50 into a is equal to 50 Newton. Therefore, you know that it's going to move with 1 meter per second square is the acceleration with which the bottom block is going to move. Along with it, the top block will also move. But having said that, the top block, will it slide over the bottom block? Let's find what is the frictional force that exists between the top block and the bottom block. F is equal to mu into normal reaction, which is 0.5 into say 200 to certain 0. So it's 100 Newton. So definitely though it will accelerate along with the bottom block, it's not going to slide over the bottom block, is what I am trying to infer from here. Find the work done by the frictional force on the upper block and on the lower block in 2 seconds. So you know the acceleration, okay, and there is the, let's calculate the frictional force that exists between the two, which is F static, because let's see if it's static. It's mu 0.5 into normal reaction, which is 200. So this itself, as I said, it's 5 to it's 100 Newton. So definitely this case is not going to, the top block 20 kg will not slide over the 30 kg block. So it's going to remain stationary, but it's going to move along with the along with the bottom block having an acceleration of 1 meter per second square. And let's find the distance through which this entire block system is moving. Ut is 0 plus half at square. You know, a into t square in 2 seconds is 4. So then s is equal to 2 meters is the distance through which it's moving in 2 seconds. The distance moved in 2 seconds is 2 meters by both the block together. So what is the find the magnetic work done by the frictional force on the upper block and on the upper block. On the upper block, you know that what exists between the two is the friction force, which is friction force, which is 100 Newton. That 100 Newton into distance moved by that will be 2. So 200 joules will be the work done on the upper block by the lower block. And so the work done on the lower block as usual will be minus 200 joules. And let me check if my answer is correct. No, what is the mistake? So we found that it's 2 meters. Till here it's correct. So the distance is 2, and you have to find the frictional force which exists. What will be the frictional force, which is the static friction which exists between the two, is I got it as 100 Newton. Yeah, that's Fs maximum, correct. Work done by the frictional force on the upper block is mu into normal reaction on the upper block. Yeah, it's mu into normal reaction, which is 20, and so you get 100 newtons. Why is it 20 into 2? Why is it 20 into 2? Oh, that's just mass into acceleration. So then are they doing mass into acceleration into distance? Okay, so then you know that it's mass into acceleration, where the upper block's mass is just 2 into 20 into acceleration is just 1. So then therefore it's 20 is the force into distance through which it's moved. So work done will be into 2, so 40 joules, and therefore here it will be minus 40, and you're supposed to calculate it with once you know the acceleration, you're supposed to calculate it with the force, and that's exactly what we did here also. We knew the acceleration. Once you know the acceleration, you're supposed to find the we just did mass into acceleration. mass into acceleration, because static friction is not always mu into normal reaction. Though this is the Fs maximum, what you got is Fs maximum. At that point it will be equal to the force applied and not Fs maximum. So you can't take 100 newtons to be the force force in here. You have to take mass into acceleration. That's a common mistake we do, and I did it, you saw it. So make sure you're correcting your mistake. Okay, so next is what else is the question? Is there another part here? That's all. Okay, is the work done by the friction force in the upper plug converted to heat or mechanical energy or both? B, the work done by the friction force in the upper plug is converted into kinetic energy, so only converted mechanical energy. I don't understand what they have written. What is the question? In B, is the magnitude of the work done by the frictional force in the upper block and lower block the same? Yes, that is true. Is the work done by the frictional force on the upper block converted into heat? Yeah, because the top block, though it's accelerating along with the bottom, it is not as such moving individually. So then therefore it is converted into heat or mechanical energy or both. Converted into its kinetic energy, so only mechanical. There is no kinetic energy because the upper block as such individually it's not moving. So I think it will develop as heat. I don't know. So only mechanical energy. I really don't understand what he has written. So what I can infer is it's not moving, so there's no kinetic energy. Upper block converted to heat or mechanical energy or both. Converted to, there is no kinetic energy means there is no mechanical energy. So it probably is converted to heat is something, but we'll discuss this in the class. So let's go to the next question. So let's deal with this question. Sum of the magnitudes of two forces acting on the body is 15 Newton. Sum of the magnitudes of two forces, F1 plus magnitude of F2 is equal to 15 Newton. Okay, the resultant force has magnitude of, the sum of the magnitude of force is 15 Newton. The resultant force has a magnitude, which means the F1 and F2 should have been in different directions so that you will have a resultant. It's I don't know what is the angle between them or anything like that, but they have given the resultant to be 12 Newton. Okay, and it is perpendicular to the large force. Oh, the resultant itself is perpendicular to the large force, which means it's not going to be like this. So considering one of the forces is largest force, the resultant itself is going to be like this. And that's what it is. They have given it like this. So this is 12 Newton and sum of these two is 15 Newton. Find the and it's perpendicular largest force. So this is your F resultant. This is your F largest. Okay, one of it is F largest, F smallest. Let me consider it like this. So this is F largest and this is the resultant. And okay, normally resultant is calculated by parallelogram law, according to which it's Fs square plus Fl square plus 2 Fs Fl cos theta, where theta is the angle between the two forces itself, correct? Which is 90 plus theta, which is 90 plus theta, but I don't know what this theta is. You understand? I don't know what this theta is. I'm going to get into soup. So let's pass this and then think. சொன்னதுன்னா இந்த தீட்டாவே தெரியாதனால angle between F and F2 தெரியாதனால magnitude of the sum of the magnitude of the forces means, does it mean magnitude of Fs plus magnitude of Fl is equal to 15? Then you can find the angle. But it's not that. Sum of the magnitude doesn't mean Fs. You understand what I'm saying? ஐயோ எப்படி மாட்டிக்கிறேன்னு. சாரி கைஸ், என்னெல்லாம் தாட் ஓடிச்சு தெரியுமா? எவ்வளோ ஈஸியாக இருக்குது சம், ஆனால் ஸ்ட்ரைக் ஆகலை. ஓகே, ஐ டெல் யூ வாட் யூ ஹேவ் டு டூ. Here's the question. Oh, the question. You have to take that. They've given magnitude of A plus magnitude of B is equal to 15. And the resultant itself is 12. அப்படின்னு எதை கொடுத்துருக்காங்க. Okay, so என்னன்னா a plus b is equal to 15 இதான் first equation. Resultant ஓட formula is root of a square plus b square plus 2ab cos theta is equal to 12. Okay, so then square பண்ணா a square plus b square plus 2ab cos theta is equal to 144. Okay, பட் இதுக்கு என்ன அர்த்தம்னு ஃபஸ்ட்டு தெரியணும். நம்ம ஏன் அதை வெக்டர் ரிசால்விங் பண்ணலை சாம்? இது வந்து ஏ வெக்டர் ப்ளஸ் பி வெக்டர், அதோட ஹோல் மேக்னிடியூட்ஸ் 15 அப்படின்னாக்கா இட் இஸ் நத்திங் பட் ஐம் ஜஸ்ட் திங்கிங், குட் திஸ் பி ஏ வெக்டர் அண்ட் குட் திஸ் பி பி வெக்டர் and so this could be the resultant, which is a plus b, whose whole magnitude itself is 12 units. Okay, so the a vector or
90 degree.
Okay, which is having an making an angle, resultant is making an angle with the larger of it. Okay, so can we do one thing? Instead of drawing b like this, can we draw b like this? You know what I'm saying? So let's draw a like this. Let's draw a like this, yes, and let's draw b like this. In that case, the resultant will make with the largest r vector to be like this. So then you know this is a vector and this is b vector. The resultant will be in the opposite direction, which will be nothing but r is equal to a plus b. Correct? So then a vector, b vector, and the resultant is your c vector. Okay, this gives you an angle. Cos theta is the angle between a and b, which is the angle between a and b, correct? And cos theta itself is a by b. Can I substitute cos theta as a by b here? Correct? So a square plus b square plus 2ab into a by b. So b and b gets cancelled. A square plus b square plus 2a square, which is 3a square plus b square itself is 144. And you already know magnitude a plus b is equal to 15. This means it's just a plus b is equal to, this is also magnitude only. So a plus b is equal to 15. Can we get a linear equation? Okay. And can we solve it? You can write a is equal to 15 minus, no, b is equal to 15 minus a. Can I substitute it here? I don't know, Sam. I'm just, I just got a hint and I'm trying to develop 3a square plus 15 minus a, the whole square is equal to 144. 3a square plus 225. 15, sir? 225. Plus a square minus 30a is equal to 144. Correct? So then this is 3a square plus a square is 4a square. 225 can go that side, so you already have a minus 30a, and minus 225 plus 144 will be 12 na 81. It will be minus 81, so plus 81 is equal to 0. Correct? 81 into 4, 8 4 are 32, 324. Can I factorize it? 324, I should get a 38. Correct? I can't even take a 3 out or anything, you see. So I'm going to get into trouble. I can see that 2 into 54, 2 into 7, 2 2s are 4, 7 2s are 14, 3 9 and a 3 3. I have to get a 30. 3 2 6, 6 2 is 12, 3 3 is 9, 9 3s are 18. Okay, so a 4a square minus 12a or minus 18a, whatever, yeah, 12a doesn't work out, will change. Minus 18a plus 81 is equal to 0. 9 is common here, no? So 4a is common, a minus 3 minus 9 is common, 2a, what? Okay, now I'm passing and seeing what he has done. அதனால் ஃபேக்டரிஸ் ஒழுங்காக பண்ண முடியல. மைனஸ் பி ப்ளஸ் ஆர் மைனஸ் பண்ணி பார்க்குறேன். மைனஸ் பி ப்ளஸ் ஆர் மைனஸ் ரூட் ஆஃப் பி ஸ்கொயர் minus 4ac, 4 into 4 into 81 by 2a. So 30 plus or minus root of 900 minus 4 4s are 16, 81 into 16, 16 1s are 16, 16 8s are 8 6 are 48, 128, 129. Huh? What? Negative? Sam. நல்லா தான் பண்ணிட்டு இருந்தோம். சாரி கைஸ், ஐம் ரெக்கார்டிங், ஐ ஜஸ்ட் பாஸ் திஸ். திங் இஸ் நான் இதில் நிறைய தப்பு பண்ணியிருக்கேன். என்னெல்லாம் தப்பு பண்ணியிருக்கேன் அப்படிங்கிறத ஸ்டூடெண்ட்ஸ்க்கு சொல்கிறேன். இது பார்த்தீங்கன்னா யூஸிங் parallelogram law. ஆனால் இது parallelogram law கிடையாது, இது ட்ரையாங்கிள் லா. நான் இதை வந்து அப்படியே ட்ரையாங்கிள் லாவாக மாற்றிட்டேன். ட்ரையாங்கிள் லாவாக போட்டுட்டு நான் cos theta எழுதுகிறேன். அதை எப்படி நான் அங்கே சப்ஸ்டியூட் பண்ண முடியும்? அக்கார்டிங் டு எதர் நான் parallelogram law யூஸ் பண்ணி போடுறேன்னா parallelogram law தான் ஸ்டிக் பண்ணும். ஸோ நான் இதை வந்து ஐம் ஜஸ்ட் கோயிங் டு ஸ்ட்ரைக் திஸ் ஆஃப். ஓகே, ஐம் சாரி கைஸ், ஐம் ட்ரைங் டு டூ சம்திங் பிகாஸ் எப்படி பண்ணாலும் ஆன்சர் வரணும். ஆனால் எப்படி பண்ணாலும் ஆன்சர் வரல, எனக்கு சேடாக இருக்குது. ஓகே, ஸோ இது வந்து நம்ம parallelogram law யூஸ் பண்ணியே பண்ணிடலாம். அண்ட் யூ நோ தட் parallelogram law பொறுத்த வரைக்கும் நான் என்ன சொன்னேன், parallelogram law 90 + θ அப்படின்னா, ஏன்னா இது ரிசல்டண்ட்டாக வரணும்னா இப்படி இருக்கணும், இந்த வெக்டர் வந்து இப்படி இருக்கணும் அப்படின்னா இல்லை, இந்த வெக்டர் இப்படி, இந்த வெக்டர் இப்படி இப்படின்னு சொன்னேன். அப்போ தான் ரிசல்டன்ட் வந்து இப்படி இருக்கும். அதனால இது 90னா இது 90 + θ. இது ட்ரையாங்கிள் லா பண்ணும்போது இது அப்படியே இங்கே இதே தான் இங்கே ப்ரொஜெக்ட் பண்ணிக்கிறோம். இந்த ஏ தான் இங்கே வருது, கரெக்டாக. இந்த பேரல் வெக்டர் தான் இதுதான் ட்ரையாங்கிளாக இப்படி மாறுது. ஸோ இஃப் ஐம் சேயிங் திஸ் இஸ் த ஆங்கிள் பிட்வீன் த டூ வெக்டர்ஸ் இஸ் θ, obviously this when I mark it in the triangle, I'm not supposed to mark it as θ. I'm supposed to mark it as 180 - θ. I'm supposed to mark it as 180 - θ. If I'm going to take this as triangle, how can I mark that as θ? Because the angle between the two, you understand what I'm saying? Sam, if this is nalla gavani, if this is a vector and if this is b vector, the resultant can be perpendicular to one of the bigger vectors, which is I'm taking a to be a bigger vector. So it is possible only when a and b are like this. So when I'm extending the a like this, correct, I'm extending a's direction, I'm just extending, I'm trying to do a like this, b like this, then this will not be θ, no, it will be 180 minus, even if I'm doing it as a triangle, the angle should have been 180 minus θ, no, if I'm doing it as a triangle. You agree with me?
இப்போ ஆனால் இதுவே 180னா அது எப்படி 180 - θ?
என்னையா இது angle between the two is θ means this குட்டி angle will be 180 minus θ. Okay, பட் அப்போ ட்ரையாங்கிள் எடுத்து பண்ணுறதா இருந்தால் பண்ணலாம். வேர் I will draw a vector, I will draw b vector. Shouldn't I be then writing this as 180 minus θ? That is my issue. So when I am writing here, I want a cos θ. I will get a cos 180 minus θ, which will be a sin θ only. No, which will be cos θ. Cos 180, but it will be second quadrant, will be minus cos θ. So cos 180 minus θ will be a by b. But cos 180 minus θ will be minus cos θ is equal to a by b. So cos θ itself is minus a by b. So when I substitute that here, you understand what I'm saying? When I substitute that here, I'm trying to do. So you don't have proper solutions. Can you see? So you have to think and do. Only clue is there. There is solution, no? There is. But complete clarity is not there. So you have a square. So you have an a plus b to be 15. And you have an a square plus b square plus 2ab cos θ plus 2ab cos θ, which is an angle between the a vector and b vector. Parallelogram law will have only a plus. There is no minus, because if you substitute 180 minus or something only it will be. But other than in that little cos θ balave, you're going to substitute minus a by b. So b and b is getting cancelled. So a square plus b square minus 2a square.
Okay.
So I am getting b square minus a square, which is equal to 144 because the magnitude of the resultant square. So b square minus a square, and you know a plus b is 15. Now I'll take what is b is equal to 15 minus a and substitute it here. 15 minus a the whole square minus a square is equal to 144. So I'm just thinking, can I do it as a plus b into a minus b? Sometimes that will help us to solve the equation. So 15 minus a plus a into 15 minus a is equal to 144. So a and a get cancelled. So 15 minus 2a is equal to 144 by 15. So then therefore 15 minus 144 by 15 is equal to 2a. 15 15s are 225 minus 144 by 15. What? அதுதான் கீழே கொண்டு வந்துட்டேனே.
Okay.
Is equal to 2a. So இதை subtract பண்ணா you get 225 minus 144 is 1. This is 12 now. You have 81 is equal to 30a. So a is equal to 81 by 30, and 33s are 90, and the 13 2s are 2. I'm getting the answer. So 81, 30, 2s are is 60. So you have a 21, put a decimal, put a 0, so then there was 7. So 2.7 meter per second square is the acceleration. How is it? Excellent, right? But that clarity, none of that clarity is there when you look at there's nothing here. So that gives you a small key as to how to proceed, and that's what is this. This is what I've been breaking my head, and every time I'm doing it. Certain sums I have good solutions, but certain sums I don't have. So now if you're learning this sum, now you will know from a video how it came and everything. Are you clear?
Yes.